Friends, good morning everyone. I welcome you all for my online learning sessions. So previous past sessions we have seen what is the inverse of a matrix, right? What are the different theorems, what are the properties of inverse of a matrix, right? Also we have seen some elementary transformations. There were totally 6 elementary transformations, 3 for rows and 3 for columns, right? What were they? First one is interchanging of 2 rows or 2 columns. That was the first elementary transformation. And second elementary transformation was multiplying a scalar to either row or column. And third one was multiplying some scalar or a non-zero constant to some row or some column and adding it to some other row or column. Right, that was the third transformation. So with that knowledge and the knowledge of inverse of a matrix, right, we will see how to find inverse of a matrix, right? So when we speak about inverse of a matrix, we know about its properties and we also know the identity A into A inverse is equal to I, or this can also be written as I is equal to A into A inverse, or I is equal to A inverse into A. All are one and the same. Okay. And also we know that A can be written as I into A. A can be written as I into A. With the help of these two equations, A is equal to I into A and I is equal to A inverse into A, we can find the value of A inverse. Right? How is that? Alright. So we know A is equal to I into A. Right? For example, let A is equal to 1, 2, 3, 4. Let A is equal to 1, 2, 3, 4. We know that A is equal to I into A. So I can write 1, 2, 3, 4 as equal to, what is I? 1, 0, 0, 1, and keep this A as it is. Should not substitute the value of A on the LHS. On LHS we should substitute, and I value on the RHS we should substitute and keep A as it is. Right? So now applying any transformation here, applying some of the transformation, we should convert the LHS part into identity matrix. We should convert the LHS part into identity matrix. What is I? 1, 0, 0, 1. We should convert the LHS part as 1, 0, 0, 1. So what should be made? This 3 should be converted into 0. This 2 should be converted into 0. This 3 should become 0. This 2 should become 0. And here 4 should become 1. So first and foremost step is you convert the elements, right, below the principal diagonal. The element below the diagonal as 0. Right? Convert the element below the diagonals as 0. So how to convert them as 0? See, 3 is there. If I subtract 3, I will get 0. If I subtract 3, I will get 0. So simply I cannot subtract 3. For that I need some transformation which will subtract 3 from this 3. Right? So how is that possible? Right? So third transformation says that we can multiply any non-zero constant to some row or column and add it to some other row or column. Right? So if I multiply 3 to first row, and once again you should be very much clear that any transformation you apply to any particular row, it will be applied to entire row, not to any element. Right? If you are applying any transformation to first row, it will apply to all the elements in the first row of this matrix. It will apply to all the elements in the first row of this matrix. If you apply to column transformation to any column, that transformation will be applied to entire column, all the elements of the column. So now what will be my, see, I can write R2 changes to 3 times R1 minus R2. Fine. 3 times R1 minus R2. 3 times R1 means what happens here? 3 into 1, it will be 3. So 3 minus 3 will be 0. Right? R2 is, what is happening to R2? It is 3R1 minus R2. You should replace all the elements of R2 with this value, 3R1 minus R2. So here 3 will be replaced by 3 into 1 minus 3. Here 4 will be replaced by 3 into 4 minus 4. Right? And one more thing, whatever transformation you apply on LHS, it will be applicable to RHS also. It will be applicable to this particular matrix also. Okay. So now, what happens here? So we are applying transformation to R2, R1 will remain unchanged. We are applying transformations to R2, so R1 will remain unchanged. 1 as it is, we will write little bit, will give a little bit distance, 2. Now this 3, this will change according to this formula, 3R1 minus R2. 3 into, what is R1? 1. What is R2 here? 3. 3 into 1 minus 3. Here, what is R1? 2. So this also will change into 3 into R1 is 2 minus R2 is 4. So here completes the application of transformations to first matrix. Here also it is applied to identity matrix here also. But first row will remain unchanged, 1, 0. Now what happens here, that all the elements here will be replaced by this formula. What is R1? 1. What is R2? 0. And here 1 will be replaced by 3 into, what is R1? 0. What is R2? Minus 1. And A will remain as it is. Okay. One as it is, 2 as it is, this is 3 minus 3 and this is 6 minus 4, right, is equal to, this is 1 and 0 as it is. 3 into 1 is 3 minus 0, 3 into 0 is 0 minus 1 and A as it is. Fine. So this is how we need to apply the transformation. Now simplify it. What is this? First row remains unchanged. 1, 2, 3 minus 3 is 0, 6 minus 4 is 2, 1, 0, 3 minus 0 is 3, 0 minus 1 is minus 1 into A. Right? So we have successfully converted this element into 0. Right? Now we need to convert this as 1. This element as 1. That is this part as 1. So first step is whatever elements are there below principal diagonal. So principal diagonal is this way. Whatever elements are there below principal diagonal. That is, here it is 2 cross 2, so only 3 is there. If it is 3 cross 3, so 3 elements will come below principal diagonal. So all the elements should be converted into 0. Once those elements are converted into 0, then only we can proceed to next one. So as all the elements below principal diagonal are 0, now next is convert the diagonal elements into 1. Convert the diagonal elements into 1. Here we already have 1, so no need to worry. Here we are having 2. So this should be converted into 1. How to convert that into 1? Suppose if I apply any transformation which will make me 2 minus 1. If I subtract 1 out here, so I will get this as 1. So I can make it by any transformation. But what happens if I apply any transformation to second row? It will be applicable to entire elements of the second row. So if I subtract 1 here, 1 will be subtracted from this 0 also. So 0 will vanish. So minus 1 will come. So that should not happen. So this 0 should remain as it is, and this 2 should be converted into 1. So how is that possible? Applying second transformation. What is that? Multiplying any constant or any non-zero scalar to any row. So if I multiply 1 upon 2 to this, then what is 1 upon 2 into 0? 0 only. This will not change. 1 upon 2 into 1, it will be, so 1 upon 2 into 2, it will be 1. So I can write row 2 changes to 1 upon 2 row 2. Row 2 changes to 1 upon 2 row 2. So what happens? Once again, first row remains unchanged. 0 by 2, and this is 1 by 2 into 2. 1, 0. 3 will be 1 upon 2 into 3, and this is 1 upon 2 into minus 1, and A as it is. 1, 2 as it is. This is 0, this is 1. So here we will get 1, 0, 3 by 2, and minus 1 by 2. A. Okay, so we got 1 and 1. What is remaining? Here there should be 0. How is that possible? Subtracting 1 here. Right? So if I subtract 1, how to subtract it by 1? R1 changes to R1 minus R2. R1 changes to R1 minus R2. So this value will not change, this value also will not change. R1 minus R2 means 1 minus 0 remains as 1 only. 2 minus 1 remains as 2. So 2 minus 1 will be 1. R1 changes to R1 minus R2. So 1 minus 0, and here 2 minus 1. But R2 will remain as it is, because we are not changing, we are not applying anything to R2 here. Here also transformation is applicable only for R1. So this is 1 minus 3 by 2, and this is 0 minus of minus 1 by 2, and this is 3 by 2 as it is, minus 1 by 2 as it is, into A. So now what will we get here? 1 minus 1 is 0, 2 minus 1 is 1. Sorry. So we should get 0 here. R2 minus 2 R1. Okay. In order to get 0, we should subtract 2. So what I will do, R1 changes to R1 minus 2R2. R1 minus 2R2. So what happens? 1 minus 2 into 0, 2 minus 2 into 1, and 0 as it is, 1 as it is, will be equal to 1 minus 2 into 3 by 2, 0 minus 2 into minus 1 by 2, and here 3 by 2 into A as it is. Okay, so now what happens here? 1 minus 2 into 0 is 1. Okay, two minus 2 is 0. This is 0. 1. Here 2 and 2 cancels, 2 and 2 cancels. So what remains? 1 minus 3 minus 2 and 0 minus of minus 1, that is plus 1. 3 by 2 minus 1 by 2 into A. Into A as it is. So into A. Okay. So now you can compare to this equation, right? I is equal to A inverse into A. This is what I, right? So this is what some matrix into A. So if I compare this both equation, I can write this as A inverse, right? So what will be my A inverse here? A inverse will be minus 2, 1, 3 by 2, minus 1 by 2. So this is what my A inverse is. Okay. So this is how we need to find A inverse, by applying suitable row or column transformation, whichever is applicable. Okay. So pause this video, take the problem and notes down here, and anywhere if you get any difficulty, so you can comment me in the comment box. Okay. Take down this one. Okay friends, I hope the previous problem is clear. Let us take up one more example and try to understand how to find the inverse. Previously we have taken a 2 cross 2 matrix. Now let us take the example and find the inverse of 3 cross 3 matrix. Okay. So obtain the inverse of following matrix by elementary transformations. So there is a 3 cross 3 matrix given. So let us consider it as A. Okay. Let us consider it as A. So we know that we can write A is equal to I into A. So I can write, what is A? 0, 1, 2, 1, 2, 3, 3, 1, 1. What is I? 1, 0, 0, 0, 1, 0, 0, 0, 1 into A, because it is a 3 cross 3 matrix, so I also should be 3 cross 3 matrix. Okay. Now what is the process? We should make all the elements below principal diagonal as 0. Below the diagonal elements as 0. What are the elements below diagonal? 0, 2 and 1 are the diagonal elements. So these are elements below diagonal elements. This is lower triangular elements. Right? We should make all of them as 0. So first let us start with 3. Okay. So how to make this one as 0? How to make this 3 as 0? So I can write R3 changes to R3 minus 3R1. So 3R2. R3 changes to R3 minus 3R2, or R3 changes to 3R2 minus R3. R3 changes to 3R2 minus R3. So 3R2 means 3 into 1 is 3. 3 minus 3 will be 0. So first row will remain as it is. 0, 1, 2. Second row also will remain as it is. 1, 2, 3. Okay. And this one here, 3 into R2 is what? 3 into 1 is 3. Minus 3, 0. This element will change according to this formula. 3 into R2. 3 into R2 is what? 3 into 1. Right? Minus R3. 3 into 1 is 3. Minus 3 is 0. Here 3 into R2. 3 into 2 is 6. 6 minus 1 is 5. Here 3 into 3 is 9. 9 minus 1 is 8. 1, 0, 0, 0, 1, 0. And here this will change according to this formula. 3R2 is what? 3 into 0, 0 minus 0 remains as 0. Okay. 3 into 1 is 3. Right? 3 into R2, that is 3 into 1 is 3 minus 0. 3. 3 into 0 is 0 minus 1 is minus 1 and A as it is. Okay. So now what happens here? We got this as 0. We need this also as 0. So what to do here? This should become 5 minus 5. So it will be 0. How to get 5 minus 5? R3 changes to 5R1 minus R2. So 5R1 here is 5 into 0, 0, 0 minus 0 will be 0. So this will not change. 5 into R1 means 5 into 1, that is 5 minus R3. So 5, it will be 0. R3 changes to 5R1 minus R3. Okay. 5R1 minus R3. So R1 remains as it is 0, 1, 2. R2 also remains as it is 1, 2, 3. And this one 5 into 0 is 0 minus 0 is 0. And 5R1 means 5 into 1 is 5. 5 minus 5 is 0. 5R1 means 5 into 2 is 10. 10 minus 8 is 2. One, 0, 0, 0, 1, 0. And 5R1 minus R3 applies here also. 5R1 means 5 into 1 is 5. Minus 0 is 5. 5R1, 5 into 0 is 0. Minus 3 is minus 3. Right? 5 into 0 is 0. 0 minus of minus 1 is plus 1. A. Okay? Fine. So this is about applying column transformation to third row. We got this value as 0, this value as 0. Now what remains is this one. This also should be converted as 0. How to convert? If I subtract 1, then I will get the value as 0. But how to subtract 1? How do you subtract 1 there? Because here also 0 is there, here also 0 is there. Right? So it is not possible directly to subtract that. Right? So before that we can make this as 1. If we make this as 1, then we can subtract it here. So how to make this as 1? So R1 changes to R1 plus R2. Right? R1 changes to R1 plus R2. So that 0 plus 1 will be 1. Right? So 0 plus 1 is 1. Okay. 1 plus 2 is 3. 2 plus 3 is 5. And 1, 2, 3. Then 0, 0, 2 will be equal to R1 plus R2. 1 plus 0. 1. 0 plus 1. 1. 0 plus 0 will be 0. And remaining as it is 0, 1, 0. 5 minus 3, 1. Okay. Fine. And into A as it is. So now this one we can make it as 0, right? So R2 changes to R1 minus R2. R2 changes to R1 minus R2. Okay. So 1, 3, 5 as it is. Then 1 minus 1, 0, 3 minus 2, 1, 5 minus 3, 2, 0, 0, 2. This is equal to 1, 1, 0. R2 changes to R1 minus R2. 1 minus 0, 1, 1 minus 1, 0. This is 0, 5 minus 3, 1 into A. So now we got this entire thing as 0. So this should be converted into 1. So I can write R3 changes to 1 upon 2 R3. R3 changes to 1 upon 2 R3. Okay. So what happens here? 1, 3, 5, 0, 1, 2. 1 upon 2 into 0 is 0. 1 upon 2 into 0 is 0. 1 upon 2 into 2 is 1. 1, 1, 0, 1, 0, 0, 5 minus 3, 1, sorry, not 5 minus 3, 1. This will be 5 into 1 upon 2 is 5 by 2. Minus 3 into 1 upon 2 is minus 3 by 2. This is 1 by 2. Right? This is what we get here. So we got this entire thing as 0 and this entire thing as 1. Now this part is to be converted into 0. This part is to be converted into 0. So what you do is, you pause the video here, take it up to this step, then we will continue with the next step. Okay? As there is limitation of space, it requires more space. So take up to here, then we will continue with the next step. Okay friends, let us continue with this one. So in previous step we have converted all the lower triangular elements as 0 and principal diagonal or diagonal elements as 1. So now what we need to do is, we need to convert all these elements which are there in upper triangle as 0. If we are able to convert this as 0, then only we are going to get the identity matrix. So then that will be identity matrix. But remember one thing, while in the process of converting these elements to 0, none of these elements should change. You should apply the transformations in such a way that only these should become 0. This entire thing should remain as it is. Okay? Fine. So how to make, first we'll start with 3. We'll try to make it as 0. How to make it 0? If I subtract 3, I will get that as 0. But how to subtract 3? So I can write R1 changes to so you can see I can write R1 changes to R1 minus 3R2. What happens? R1 minus 3R2. 1 minus 3 into 0. 3 into 0 is 0. 1 minus 3 into 0 will be 1. Right? So what happens here? 1 minus 3 into 0. So 1 minus 0, that is 1. 3 minus 3 into 1. 3 minus 3 into 1. So 3 minus 3 is 0. Then 5 minus 3 into 2. What is 3 into 2? 6. 5 minus 6 is minus 1. And this will remain as it is. 0, 1, 2, 0, 0, 1 will be equal to, see here also R1 will change. R1 minus 3 R2. 1 minus 3 into 1 is 3 into 1 is 3. 1 minus 3 is minus 2. Okay. 3 into 0 is 0. 1 minus 3 into 0 means 1 minus 0. That will be 1. And 0 minus 3 into 0. That is 0 minus 0. It will be as it is 0. So remaining everything will remain same. 1, 0, 0. 5 by 2 minus 3 by 2. 1 by 2 into A. So now this element we got it as 0. Now these two elements should change as 0. So let us make this as 0. How to make this as 0? Here minus 1 is there. If I add 1, this becomes 0. Where is that 1? That 1 can be taken from R3. So I can write R1 changes to R1 plus R3. So what will I get? See, 1 plus 0, 1, 0 plus 0, 0, minus 1 plus 1, 0. So 0, 1, 2 as it is, 0, 0, 1 as it is. This will be R1 plus R3, minus 2 plus 5 by 2, 1 minus 3 by 2, then 0 plus 1 by 2, R1 plus R3. This is minus 2 plus 5 by 2, 1 plus of minus 3 by 2, that is 1 minus 3 by 2, 0 plus 1 by 2. Everything else will remain same. 1, 0, 0, 5 by 2, minus 3 by 2, 1 by 2 into A. Okay. So I got these two as 0. This 2 should be converted into 0. So how will I get that 2 as 0? So R2 will change as R2 minus 2R3. R2 minus 2R3. R2 changes into R2 minus 2R3. What happens here? R1 remains as it is. And R2 minus 2R3. 0 minus 2 into 0. 0 minus 0 will be 0. 1 minus 2 into 0. 2 into 0 is 0. 1 minus 2 into 0 will be 1. 2 minus 2 into 1 will be 0. This 0, 0, 1 will remain as it is. So what is the simplification? Minus 2 plus 5 by 2. If I take LCM, this will be minus 4 plus 5 by 2. That is 1 by 2. And this is 2 minus 3 by 2. Minus 1 by 2. This is 1 by 2. I have not changed this one. Just I have simplified. And R2 is what? Now we are applied to R2. R2 minus 2R3. Right? So 1 minus 2 into 5 by 2, then 0 minus 2 into minus 3 by 2, and here 0 minus 2 into 1 by 2. Okay, that is what we get here. Then this is 5 by 2 as it is. minus 3 by 2. This 1 by 2 we can write here, and 1 by 2 into A. Okay, so I hope this one is clear. So let us continue it here. So we got this entire thing as identity matrix. So this is 1 0 0 0 1 0 0 0 1 is equal to what we got here, 1 by 2 minus 1 by 2 and 1 by 2. Okay, 2 and 2 cancels. What remains? 1 minus 5. 1 minus 5 is minus 4. Then here 2 and 2 cancels. 0 minus of minus 3, that is plus 3. And here 2 and 2 cancels. 0 minus of 1 is minus 1. And bottom remains as it is. That is 5 by 2 minus 3 by 2 and 1 by 2 into A. This is 1 by 2 into A. So now we know that I is equal to A inverse into A. So as I is equal to A inverse into A, what will be our A inverse? This particular matrix. Okay. So A inverse will be 1 by 2 minus 1 by 2, 1 by 2 minus 4, 3 minus 1, 5 by 2 minus 3 by 2 1 by 2. So this is what the required inverse is. So you should carry on the transformation till you get the identity matrix on the left hand side. Once you get the identity matrix on the left hand side, then whatever is there on the right hand side except A, that matrix will be your inverse matrix. So this is the inverse. This is the procedure here, right? So you pause this video and take the notes down. Anywhere if you don't understand, you stop the video there, you observe carefully, you will definitely understand. This is simple algebraic calculations, right? So still if you find it difficult, then you can comment me in the comment box. Okay, so pause this video, take the notes down. So friends, I hope you have taken down this problem and I hope it is clear. So what you do is, you take the many problems and try to find the inverse, right? You have many problems in your textbook, right? You try to find the inverse of that. Okay, so this problem you can take it as homework. Okay, okay, so these two problems you can take it as homework, try by yourself and let me know the answers and any difficulty you are facing over here, and let me know that also. Okay, so I will come up with the answers of these problems in the next session. So till then, you keep it trying. Okay, thank you.